Hi and welcome. My name is Isam. I'm the senior designer and architect at ISD Architects. In this video we're going to follow up on our last video, which talked about the global warming and how architects as well as every individual can help fight back this phenomenon and hopefully stop it and push it even further. Now, architects have a great role to play because buildings have a lot to do with the production of carbon dioxide, whether through the manufacturing of materials, construction materials, concrete, wood, steel, metal, porcelain, etc., or in the construction process itself, assembly, or the transportation of materials, and so on and so forth. So in addition to that, the building themselves use a lot of energy for heating and cooling depending on the climate. So in cold weathers, the heating degree days are much higher than cooling degree days. Therefore, the building uses more energy for heating, and vice versa for hotter climates or warmer climates. Air conditioning is the norm and also consumes a lot of energy, and if it's still even though it's electrical energy, there are gases associated with that and released into the atmosphere. So the architect's role is to minimize the energy consumed for heating and cooling, and that's a major concern for architects. That's why passive design tactics and passive design strategies are come into play. Meaning, how can we maximize the orientation, as we mentioned before, the location of the building, the orientation of the building, the number of fenestrations, the number of windows, and how we can utilize, for example, in the spring and the fall, the possibility of cross ventilation as a cooling mechanism and other means for heating mechanisms passively. That, you know, when you receive the sun in a room that is glazed and well insulated and glazed towards the sun, then the heat will be trapped inside, and it will be heat the floors and the material around it, the furniture, the carpets, everything will be heated, and then it will be emitted during the night. How we can use these tactics and strategies to achieve that. In this video, I'm going to talk about a detail though. This detail has to do with moisture. Now, to say that we design green buildings is not only about heating and cooling, nor is it only about CO2 emissions. It's mainly, in my view, about the health of the residents, the health of the people living and working in this building, inside this building. Many statistics say that we stay indoors for a very, very long time. Probably 80 to 90% of our time is indoors, whether we are at home or we are in the office or we are at the gym. It's all indoor environments, and therefore what we breathe, what we sense as a temperature, and so on and so forth, is also controlled, or they're all controlled by indoor environments. In this detail that I've just sketched, it shows a typical wall section of a building, mostly residential building, but it could also apply very well on a commercial building. In this detail, which is a cross section of a typical wall, we see a brick veneer, an air gap, a house wrap, what we call, or a felt layer or sheets, and then sheathing, which is the boards that wrap the building or enclose the building, and then the metal studs or the wood studs which house the insulation, the batt insulation, And then we have another red vapor barrier, and then the gypsum wallboard, this one, or the drywall. Now what's wrong with this? I mean, this is a common practice, but I have a word here about this common practice that could turn into a dangerous situation in certain scenarios. Now imagine that the sun is shining and the temperature is normal. Let's say it's 20 degrees Celsius, 20 degrees Celsius inside, and then you have the sun shining and heating the brick veneer. Now when it heats the brick veneer, the air inside this air gap gets heated up a little bit more than the outside and the inside as well, because this is obviously a controlled environment, but this is, it could drop to cooler levels, or it could go high depending on the general conditions around the building. But this one becomes hot, and considering the vapor inside the air, then this would be higher pressure here for the vapor than the vapor pressure outside and inside. Now the vapor moves when there is a vapor pressure differential. So when you have a higher vapor pressure area and a low vapor pressure area, the vapor tends to move to the lower pressures. So in this case, in this scenario, when this gap is not ventilated enough, that keeps it enclosed or entrapped, then the vapor pressure here will travel definitely to the outside and to the inside. Now this might have different outcomes when it goes through the brick veneers, but the most crucial part is when the vapor travels inward into the house. And by all means, we would like to prevent the house from getting moisture that we cannot control, or it might sneak behind the wall and cause damage to the wall. Now when the vapor travels from this air gap into the inside of the wall, it could face a cold surface if there is an AC here, air conditioning. So these areas would be colder, which may cause condensation here of the vapor, and that will cause accumulation of vapor inside the wall assembly here, which has, of course, the batt insulation. The other danger, or the most crucial mistake that many of us, I would say, do when building a wall, is to put the vapor barrier, which is a polyethylene, the 6 mil polyethylene vapor barrier, inside while this scenario is happening or is composed. Then the vapor will travel and there is nowhere to go from there. It is entrapped inside the wall assembly, and this is a dangerous situation. Now what happens is that the vapor stays here. It can not go back because of the vapor pressure differential. It stays there, and as I said, when it faces a cold surface, then it tends to accumulate as water drops. This causes the batt insulation, which is a fibrous material, to absorb moisture until it's soaked, especially at the bottom of the assembly, causing all sorts of problems and structural problems, of course, decay of the base plate or the wood studs themselves. In addition to the efficiency of the batt insulation itself, has thermal insulation, and also it can cause, over time, if this is repeated enough, for mold to be created here, because mold loves moisture and heat and darkness. So when the mold happens, then this wall assembly becomes a source of sickness, a source of disease, illnesses for the residents inside the building. So this little detail, which is called a common practice, could be a source of all kinds of problems if attention is not paid to the layering of the wall assembly and to the permeability of this vapor barrier versus the permeability of the air barrier, and I'm talking about these two red layers. These are crucial points. Even though they might look so technical, they could ruin any beautiful design, any well laid out house or building by making the wrong detailing. And of course this is a generic problem, but around the windows, around the openings, the jambs of doors, there are other problems that could occur, especially when there is an air leakage or there are sockets for electrical sockets, for example, and they are not sealed around that opening, and all sorts of things that could cause the air infiltration or exfiltration through the assembly. Now, to wrap up, we need the air gap to be aired. This is very important. So we need the air to come from below and exit from above, so that we have a well-aired air gap here. This is an air gap, without which, as I said, the temperature here with the moisture would have nowhere to go, so it expands to the lower vapor pressure areas, which tend to be the inside. We need to air ventilation, as I said. So air gap alone is not enough. It has to be well ventilated, and we need to be careful about the poly. This is the common name for the polyethylene. The 6 mil poly, we cannot use it anywhere. We have to be careful, because if there is this situation, this would be a curse, not a solution. This would be a problem, rather be a solution. Why? Because it entraps the moisture or the vapor inside the wall assembly, causing it to decay over time, of course. The air barrier is also a fourth thing that I would like to draw attention to. We need to make sure that the air barrier is an air barrier, not a vapor barrier, because if it's a vapor barrier, then it will also create a barrier to the vapor entrapped here and would not be able to escape. So that's why this permeability, this material's permeability, has to be much higher than the polyethylene permeability, which is really minimal. It's a plastic, it's a nylon or plastic that really cannot let any vapor through it, while the air barrier is a fabric that prevents the wind from entering the house or the structure, while maintaining the vapor to move freely across that material. So I hope you found this video useful, and I would welcome any questions or concerns or any opinions to discuss under this video. I also invite you to go to our website, isdarchitects.com, and check out our free report that talks about the 4 major problems that could cause any design to, or any structure to fail even at the design stage. Thank you very much for watching. This has been Isam from ISD Architects.